All year in Algebra 2, we solve equations and we graph equations. That is what you do in Algebra 2. So we're going to continue solving equations, and today, instead of solving equations, we're going to solve inequalities. Do you know what inequalities are? I bet you've seen these before. Those are inequalities. Which one's a less than? The top one is a less than. Now, when I was taught about these, I was taught about the alligator. Were you taught about the alligator? And so when I started teaching this, I didn't know the names. All I knew about was the alligator. If you never were taught about the alligator, that's okay. You don't have to know the alligator. But I had to learn the names, and I couldn't remember the names, and it's real embarrassing to stand up here as a teacher and say the wrong name. So I finally, the way I taught myself is if it points to the left, it's a less than. There are all kinds of different memory devices, but that one worked for me. If it points to the left, it is a less than. So in example number 1, we have a example of an inequality. So right underneath the number line in example number 1, would you write this math sentence down? What's the difference between this math sentence and that math sentence? This one has an inequality sign, this one doesn't. Write this one down and solve it. Can you solve that without any help? You should be able to solve something this simple without any help. Did you get 2? Now, what's the difference between this and the original problem? The original problem has an inequality. The only difference to solving an inequality in this particular example is the inequality. It is exactly the same except for one rule that we're going to look at in the next problem. This problem is exactly the same as if you had an equal sign. But how do you graph it? First of all, why are we graphing it just on a number line? Most of the graphing we will do will be on the XY plane. Why are we just graphing this one on a number line? Well, this is the XY plane. Do you see any Y's? So if we don't have any Y's, what's left? The X just in one direction. So we're only solving for X, so we're only graphing in the X direction. Well, how do you graph this? Well, the answer was 2. So you put a circle at 2. Now, what does this part down here mean? Or equal to. So it can be equal to 2, so you color in the circle if there is an or equal to line. Now, if you have this set up correctly, where X is on the left, this arrow tells you which way to color from that 2. This points to the right, so I color to the right. This is where the numbers that are greater than 2 are located. So if the X is first, like it's supposed to be, then this tells you which way to color. Now, we have it solved. We have the number line. What does the number line mean? What does it mean when you color in all this part of the number line? Means any of the numbers over here, any number over here, including the 2, if I filled them in for that X, it would make a true math sentence. If I put a 2 right there in place of X, it would make a true math sentence. If I put a 3 right there, or a 4, or a 5, or a 6, or a 989, any number greater than 2 will make a true math sentence, including decimals. 3.5, 9.8, including fractions, 99 over 10, or any other fraction that is bigger than 2. So this is not only whole numbers could be substituted in there, it includes decimals and fractions. It includes all numbers bigger than or equal to 2 as part of the answer. That's what it means when you color in the number line like that. On problem number 2, once again, write the problem down with the equal sign and solve it just like the equal sign was not there. Except that when I solved it earlier, I made a sign mistake. Don't make a sign mistake. You subtract 23 from both sides and you get a negative 12. Divide by a negative 4 and you get a positive 3. So, solving the inequality is almost the same. This is a less than sign, so that would be a less than sign. So this would be a less than sign, except there's one rule that makes inequalities different than equalities. If you multiply or divide by a negative, it switches the inequality. When you divide by a negative, it changes a less than to a greater than. You may have heard of that rule before. So, when you multiply or divide by a negative number, it switches less than to greater than. And so, that means I'm going to put my circle at 3. There's no or equal to. This tells me to shade in to the right. When you multiply or divide by a negative, it switches the inequality sign. You have that written in your notes. And I wouldn't be surprised if somebody asks you about this when you get to class tomorrow before you even get in the door. Somebody might ask you this question. You're going to be ready for it? So, you solve inequalities exactly like equals, except for that one rule. So, what are we going to do with problem number 3? What are you going to do first? Now, you don't have to put the equal signs in it like I did in problem 1 and 2 and then change them. I was just putting that in there to make a point. You can go ahead and distribute here and put in the greater than sign, and then we're going to solve it with the same steps we would use if there was an equal sign. So what are we going to do with 8? Subtract 8 from both sides. That is not going to switch the inequality sign. Only when you multiply or divide by a negative, not just every time there's a negative. Okay, what am I going to do with the 18? That's not going to switch the inequality. Not every time you divide, but when you divide or multiply by a negative. So 3 is the answer, so we circle the 3. This has an or equal to, so you color in the 3, and then this goes to the right, greater than 3. So you're going to solve and you're going to graph. Now, there's more than one way to solve this particular problem, and so would you please write it down? When you solve an inequality, when you get to the bottom, the x needs to be on the left. Doesn't really make a lot of difference on equalities, but when you solve inequalities, the x needs to be on the left. So I am going to start out by subtracting the 5x from both sides. If you started out a different way, just wait. We're going to come back to you in just a minute. So, we're going to subtract the 8 from both sides. This higher math. What is 5 subtract 5? You have to put the 0. Continue solving. Negative 8x. Divide by negative 8. Cancel out the negative 8. And the answer is negative 1. But I divided by a negative. So what has to happen to the less than sign? It becomes a greater than sign. So I am going to, oops, that's not right. What am I going to circle? Negative 1. Am I going to color it in? Doesn't have the or equal to, it points to the right. Any number bigger than 0 will make, bigger than negative 1 will make that true. You have that much written down? There is another way to solve this one. You could start out by adding the 3x to both sides. I'm solving for, you don't have to write it down twice, but you can just look up here. Does this say to go in the opposite direction? No, it doesn't. Because if you listen to what I said, this tells you which way to color if the x is on the left. Is the x on the left? When you write your answer to an inequality, you should put the x on the left. If I turn the problem around, I also have to turn the sign around. This is where the little rule about the alligator eating the bigger fish helps you. Because if this is the alligator mouth, it eats the x. And so if you turn it around, the alligator mouth still has to eat the x. If you weren't taught about alligators, that's okay. The x, it's opening up to the x, so this one is opening up to the x. So did I actually get the same answer? I still have the same answer. The reason I would not suggest you do it this way is because everybody forgets the last step. On an inequality, when you solve it, the final answer needs to have the x on the left to be in correct form. Now you will notice I skipped problem number 5 and 6. I skipped problem 5 and 6 because we're going to talk about those two tomorrow, and we're going to go ahead and talk about 7 and 8. This is called compound inequalities because there's more than one. Do you see 2 inequalities? Guess what you do with 2 inequalities? Solve them both. And so hopefully this will be fairly easy to solve. Subtract 3 from both sides. And there's the first one. Now, this is what I see a lot on this kind of problem that is incorrect. What is wrong with dividing by negative x? Right, and what's negative x divided by another negative x makes a 1. That's what you get when you divide by negative x. I still haven't solved for x because it's still there. It's still not isolated. And so what you should be solving, dividing by is negative 1. I don't want to cancel out the x. I just want to cancel out the negative. Negative divided by a negative makes a positive. And when you divide by a negative, it changes the less than into a greater than. And so, all of this is the answer. There's two parts to the answer because there was two parts to the question. Sometimes, instead of seeing the word or, just in case you see it sometime, you will see the letter U in between those. U stands for union. It means the same thing as the or. You have two parts to the answer, so you have to graph both parts. This has a circle at -1. It doesn't have an or equal to, and it goes to the left. This has a circle at 4. It does have an or equal to, so the circle's colored in, and it points to the right. So, if you have two parts to your problem, it's called compound. What do you do with the two parts? You solve the two parts. And I'm going to subtract 5 from both sides. X is less than -4. On this part, I'm going to divide by -2. When you divide by a negative, it switches the less than to a greater than. All of this is the answer. The answer has two parts because the question had two parts. You graph both of the parts. This part down here has a circle at -4. This doesn't have an or equal to, so it's an open circle and it goes that way. This has an or equal to, so I have a closed circle at 3, and this goes to the right. Do you think you can do this?